Greetings, Judy. I am Ashutosh Jha. I am from Tata Motors Commercial Vehicle Engineering side from Pune, India. I will let you through our presentation. Our innovation idea is driving sustainability through low carbon footprint material innovation for Tata vehicles. This is the content for our presentation. We will explain you this content one by one. This is executive summary. So we know the climate change is one of the most pressing challenge for our time. With global and national target pushing for significant CO2 reductions, Tata Motors commercial vehicle has committed to achieve net zero emission for our commercial vehicles by 2045. We adopted a quality driven framework using advanced tools to ensure our solutions were both robust and sustainable. Innovations in material and process optimization played a key role in reducing our environment footprint. If you will see the impact, these innovations led to a CO2 reduction of nearly 969 tons annually, which is equivalent to planting over 15,000 trees. We also achieved significant saving in paint, fuel and material costs while improving air quality by reducing the volatile organic compounds. Our efforts directly contributed to 4 key sustainable development goals, including climate actions and good health. This alignment ensures our innovations are not only impactful but also globally relevant. Through innovation, quality and commitments, Tata Motors is driving meaningful change towards a sustainable future for commercial vehicles. This is introductory slide. So basically, if you will see this slide on vertical axis, we have mentioned the offerings, whether that is sustainable or not. On the horizontal slide, we are seeing the how efficiently we use the resource. If you will see, we need to move from the bottom left corner to the top right corner, which is the sustainable development, the true sustainable development, where we will use the resource efficiently and the offerings will be sustainable. Let's now look at the core challenge we are addressing, which is reducing CO2 emission in truck manufacturing. See, the automotive sector, particularly commercial vehicle, is a significant contributor to carbon emission and resource depletion. Within this, one of the most energy intensive and heavy area is the paint shop operation. These operations rely heavily on baking oven and consume large volume of materials, and this leads to 3 major issues. A high carbon footprint, which directly impact our sustainability goals. The second, elevated operation cost driven by energy and material inefficiency. And third, the growing risk of non-compliances with global climate targets like the Paris Agreement and India's national commitment. With Tata Motors commercial vehicle aiming for net zero by 2045, we recognize that incremental challenge won't be enough. What's needed is a transformational shift. That's where innovative low carbon solutions that reimagine how we operate. Now, this challenge set the stage for the approach and innovations we will discuss next. To understand where we can make the biggest impact, let's take a closer look at the energy consumption across the paint shop process. This flowchart represents the typical stages involved in painting a truck body, starting from body in white and ending painted BIW. Now the process begins with pre-treatment followed by e-coating, both of which consume significant energy and material resources. As we can see, multiple baking stages and material applications contribute heavily to overall energy consumption and carbon footprint. This analysis is critical as it helps us identify which step offer the greatest opportunity for optimization and innovation. Reducing energy consumption in these stages is not just about cost saving, it's about aligning with our net zero goals and driving sustainable manufacturing practices. To further understand the challenge, let's look at the energy consumption across different stages of vehicle manufacturing. This analysis, based on industry data and internal assessment, break down energy uses into key areas, which are body shop, paint shop, line, motor pool, and shipments. But the most striking insight comes from the paint shop. The paint system alone consumes between 30% to 50% of the total energy and material used in entire manufacturing process. This makes it the single largest contributor to energy consumption and carbon footprint in our operation. Given this, it's clear that any meaningful reduction in CO2 emission must begin with rethinking how we operate our paint shops. And this insight has guided our innovative efforts and our focus on the paint shop energy consumption and material consumption reduction, which we will explore in the next section. To drive meaningful change in sustainability, we did not rely on guesswork. We followed a structured, quality-driven methodology. At the heart of our approach is sustainable material innovation. This is the central theme that guided every decision and improvement we made. Surrounding this are the 7 key quality tools and methodology that enabled us to deliver robust, scalable, and impactful solutions. Together, these tools form a comprehensive framework that not only improved our process but also aligned them with our sustainability goals. This methodology was key to achieving the results we will now explore in the impact section. These slides explain the methodology and quality tool, what we have used and how that has helped to achieve sustainability and reduce CO2 emission in our project. So first is quality functional deployment, QFD. This has helped us convert customer and sustainability need into material design targets such as corrosion protection combined with a low carbon footprint. Design of experiment DOE tools allows us to utilize and optimize sealant and e-coat formulation, reducing material energy uses with minimal trials. When we applied the DFMEA, design failure mode and effect analysis, to identify risk to integrating new material and processes, ensuring durability and safety while reducing energy intensive steps. Through RCA root cause analysis, we pinpointed high energy steps like the pre-gel oven and to eliminate them for significant energy saving. Using Kaizen, we achieved continuous improvement during lab, pilot, and plant trial, driving key sustainability gains. Our life cycle assessment LCA quantified CO2 emission reduction and validated environmental benefits across the product life cycle. Finally, total quality management embedded sustainability into our organizational culture and ensured a strong cross-functional alignment. Together, these tools formed a robust framework that enabled us to deliver impactful sustainable innovation. This slide shows the timeline. So from the starting till the end, this slide also shows where at each milestone what quality tools has been used and how they have helped achieve this final goal. This slide showcases the key innovations that help us significantly reduce energy and material consumption in our paint shop operations. Let's start with the process flow. Traditionally, the paint shop involves multiple stages starting from BIW, moving through pre-treatment, e-coating, and several baking steps before reaching the final painted BIW. Now, 2 major innovations were introduced in this flow. First is the e-coat stage. We developed advanced high-throw power e-coat. This was achieved by incorporating a branch epoxy resin structure with flexible hydrophobic segments, and this result reduced both material consumption and baking temperature, leading to lower energy uses. The second, we introduced a wow sealant, which is wet on wet sealant. This breakthrough allows us to eliminate baking stage 2 entirely, which was previously a major energy consumer. By making this oven, we achieved a substantial energy saving and reduced operational complexity. These innovations were not just about efficiency, they were designed with a broader sustainability focus. As highlighted below the diagram, our goal included reducing material consumption, reducing energy consumption, eliminating hazardous steps, minimizing waste, and utilizing waste effectively. In summary, by developing a high-throw E-coat and WOW sealant, we have made significant strides in reducing both energy and material consumption, aligning our operation with our net zero goals and global sustainability standards. This slide summarizes the tangible outcome of our sustainability initiatives and how they align with the United Nations Sustainability Development Goals. The four United Nations Sustainability Development Goals, SDG 3, which is good health and well-being, SDG 9, which is industry innovation and infrastructure, SDG 12, which is responsible consumption and production, and SDG 13, the climate actions, are directly impacted as prescribed in the table above. These slides highlight the unique breakthrough that set our innovation apart, not just in terms of performance but also in sustainability and process efficiency. Let's begin with how we have revolutionized process efficiency. We successfully eliminated the pre-gel oven baking step, which was one of the most intensive stages in the paint shop. This not only reduces energy consumption but also simplifies the overall painting process. Importantly, we achieved this without compromising the corrosion protection. The integrity and durability of the vehicle remain intact even with the streamlined process. This makes a significant step towards sustainable manufacturing, enabling a more agile and energy efficient production environment. Now let's look at the material innovation that made this possible. We developed a wet-on-wet sealant formulation featuring a novel polymer backbone and adhesion promoter. This allows paint to be applied directly over wet sealant, eliminating the drying and reducing cycle time. We also introduced a high-throw E-coat using branched epoxy structure. This enhances internal surface coverage and corrosion resistance, especially in complex vehicle geometries. Together, these innovations not only improved performance and durability, but also significantly reduced energy usage and operational cost, making our manufacturing process more sustainable, efficient, and truly future-ready. Now, this slide highlights the dual impact of our innovation. That is, on one hand, it has environmental sustainability impact. On another hand, it has financial efficiency. Let's start with the environment benefit. By implementing sustainable material and optimizing our paint shop process, we have successfully 969 tons of CO2 emissions annually. To put that into perspective, it is equivalent to planting over 15,000 trees every year. These results clearly demonstrate that sustainability is not just good for the planet, it's also good for business. By reducing waste, utilizing energy efficiently, and reducing emission, we are creating a more responsible and resilient manufacturing ecosystem. With these benefits, Tata Motors commercial vehicle is setting a benchmark for sustainable industrial innovation. Thank you for listening. I appreciate your efforts. Thanks a lot.